Okay, we're at the bottom of page 5 of our Chapter 3 notes, Part 1. I need you to try questions 1 through 6. It goes on to the back page. So try 1 through 6, pause the video, and then turn it back on when you're ready to check your answers. Okay, so the answers are, circle the symbol for congruent. That's the equal sign with a wavy line on top of it. We're going to classify each angle. This one is bigger than 90, so it's obtuse. This one equals 90, so it's a right angle. And this one is less than 90, so it's acute. Okay, perfect. The next page says, use the diagram at the right. Underline the correct point to complete each sentence. So the interior, that's inside of the circle, contains A is the only one that it contains. The interior of the angle contains, that would be point B, because this angle opens up and B is on the inside. Next one says, underline the correct word to complete the sentence. The end point of an angle is called its vertex. The shared endpoint, right here is the angle, or it's just B. 3 other names for angle ABC. So we can name it, you can just switch the order and say angle CBA. You can name it by just its vertex, since there's only one angle B. You can use the number that they put in the angle to name it as well. So those are the 3 other names for that angle. Okay, so our new stuff for today is talking about the different angle pairs that we talked about in the last video. We had corresponding angles, alternate interior angles, alternate exterior, and consecutive interior angles. These are not that interesting angle pairs if you're just talking about 2 random lines cut by a transversal. But anytime you have parallel lines cut by a transversal, then this gets a little more interesting. So in the picture, I can tell P and Q are parallel because they both have this arrow that's in the middle of the line. So I'm going to make it a little darker so I make sure I can see it. Okay, so we have 2 lines that are parallel. We have this line, that's line T, is the transversal. It intersects 2 separate lines. That makes it a transversal. And it makes a set of 4 angles up top and a set of 4 angles down on the bottom. So a total of 8 angles. Okay, so the first theorem says if 2 parallel lines are cut by a transversal, which is what's happening in this picture, then the pairs of corresponding angles are, I want you to put congruent to finish that sentence. They are congruent. So that means if I look at angle 4, it's going to be the same angle as the angle that's in the same position down here. So angle 4 is the lower right. So the lower right here is 8. So angle 4 is congruent to angle 8. And just in case you have forgotten, corresponding, the way to remember how to find these are they're angles that are in the same position. Okay, so there's 4 other pairs of corresponding angles. I'm just going to write one. Well, maybe we'll write them all. So let's see, let's try angle 5. Angle 5 is down here. That's the upper left. So move to up these up here. The upper left is angle 1. Let's try angle 3. Okay, so the corresponding angle to number 3 is angle 7. Another way to do these is if you imagine some mental scissors cutting out angle 3 and taking that angle and just sliding it down, angle 3 would end up being on top of angle 7. So these are the same. And then the last group we don't have would be angle 2. Goes with angle 6. Okay, so those are the 4 pairs of corresponding angles that are congruent. Okay, so then the alternate interior angles starts out the exact same way. If 2 parallel lines are cut by a transversal, which is what is happening in this picture, then the pairs of alternate interior angles are, and we're going to finish this sentence with congruent again. Okay, so just a reminder from the last video, alternate interior angles, if you look for a Z in your diagram, or sometimes it's an N or an S, I just remember Z. that will tell you where the alternate interior angles are. They have to be on opposite sides of the transversal, on the inside of the parallel lines. Okay, so if I look, 1 and 2, 7 and 8 are on the outside of the parallel line. So those are not going to be included in these alternate interior angles. The first one I'm going to write is angle 3. If I look at angle 3, there's a Z hidden in my picture right here. So the Z goes around angle 3 and angle 6. So the other angle that goes with angle 3 is angle 6. They're both on the inside of the parallel lines. 3 is on the left of the transversal and 6 is on the right. And then the only other set is if I make, instead of a Z, if I do an S right here, you would get angle 4 is congruent to angle 5. Okay. The next one says alternate exterior angles theorem. Unfortunately, there's not a real quick reference that I can make. It doesn't make any letters for this one. It's the same situation. All these start with the same thing. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Okay, so now we're going to talk about angles on the outside. So that would be 1, 2, 7, and 8. We're not going to use 3, 4, 5, and 6. So if I start with angle 1, I need to choose an angle from this set down here that's on the opposite side of the transversal. So that's going to go with angle 8. 1's on the left, 8's on the right. And then the other group, I'm going to start with angle 7. Angle 7's on the left. I need outside and on the right, so it's going to go with angle 2. Okay, this last one is the twist. So if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are not congruent. It's supplementary. So this is the only one that's different. And then in the picture, you usually can find the consecutive interior angles. It'll look like either a C or a U or an N, just kind of this boxy shape. So up here, if I make a C this way, angle 4 and angle 6 are on the inside of the parallel lines. They're on the same side of the transversal, which is what we are using for consecutive. So put angle 4 plus, put the measure of angle 4, plus the measure of angle 6 is 180. And then we can also have a backwards C and get over here, these two have to be equal to each other. They're not equal to each other, supplementary. So the measure of angle 3 plus the measure of angle 5 is 180. Okay, so because of vertical angles, there's only two different angle measures in this whole picture. If you choose any two angles in this picture, they're either going to be equal to each other or they'll add up to 180. And the real quick way to figure that out without determining which angle pair it is if both of the angles are obtuse or they are both acute, then they have to be equal to each other. But if one's acute and one is obtuse, they have to be supplementary. Okay, so let's try some problems here. So this says which of the angles measure 120 degrees, and then we're supposed to explain our reasoning. So I would start by saying angle 4 has to be 120 degrees because those are vertical angles. You can ignore this half of the picture, and angle 4 and 120 are the same. So I'm going to put angle 4 because vertical angles are congruent. Now I'm going to use the angle pairs that we just learned about. So I think the easiest one is corresponding angles, the ones that are in the same position. So if I'm going to figure out which one's corresponding over here. If you cut out angle 120 and slid it over to here, 120 would land exactly on angle 5. This is the top left. This is the top left. So I'm going to say it's congruent to angle 5. And that reason is because corresponding angles are congruent. The reason's actually a lot longer, that corresponding angles are congruent when two parallel lines are cut by a transversal. But I'll know what you mean if you just write their corresponding. Okay, then the last one that 120 is congruent to, so we had 120 and 4, and then we had 5. 8 is vertical from 5, so I know it's got to be, this 8 also has to be 120. So angle 8. And then my reason for that, I want to see if I can come up with a way to relate 120 and 8. Those two are on the outside of the parallel lines, so they're on the exterior, and they're on opposite sides of the transversal. One's above and one's below. So that one's going to be alternate exterior angles are congruent. Okay, so the next one we have a proof to fill out, and this is kind of different. All the proofs we've done so far, we usually fill in the reasons, and this time we're going to fill in the statements. So we've got a picture that's very similar to what we've been doing. The given information is A is parallel to B, and we want to prove that angle 1 and angle 7 are the same. So you should know angle 1 and 7 are the same because they're alternate exterior angles. But we're going to pretend we don't know that yet, and we're going to prove it in another way. Okay, so the first reason is given, so the information that was given is A is parallel to B. I'm going to write that in there. And then the next reason says if lines are parallel, then corresponding angles are congruent. Put an N in there. So in this picture, there's only one set of corresponding angles that are marked. So angle 1 is the only group up here, only number up here. So it's got to be something with angle 1. So if I cut out angle 1 and slide it down, it's going to appear exactly on top of angle 5. So we're going to put angle 1 is congruent to angle 5. Okay. Now it says congruent angles have equal measures. That's the definition of congruent angles. Well, we have congruent angles here, so now they're saying they have equal measures. So to write it that way, we'd say the measure of angle 1 equals the measure of angle 5. Okay, because they have to have the same measure. Okay, then this one says vertical angles are congruent. So in this picture, there's only one set of vertical angles that are marked. In this grouping here, the angles that are opposite each other in an X are 5 and 7. So angle 5 is congruent to angle 7. And then we've got the same, 3 and 5 are the exact same. Congruent angles have equal measure. I'm going to rewrite step 4, but as measures, measure angle 5 equals the measure of angle 7. Okay, then the transitive property of congruence says that if two things are equal to the same thing, so both of these are equal to angle 5, there's angle 5, here's angle 5, then those two things have to be equal to each other. So we're going to put the measure of angle 1 equals the measure of angle 7. And then here we have angles with equal measures are congruent. You'll notice that's kind of the converse of 3 and 5. So I'm going to switch this so it says angle 1 is congruent to angle 7, which is what we were trying to prove. So that is the end. You can put a little box.